Alright, hello once again. Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development Program, and in particular the AWD 1112 Application Programming with Java class, I've been doing a series of video presentations based on the two textbooks used for the class. I'm still in the first textbook, Java Quick Syntax Reference. I've done the first 15 chapters, which puts me up to chapter 16, and there'll actually be 23 and not 22. Alright, so chapter 16, which is on constants. Alright, the biggest difference between constants that we had in C# and constants that we have in Java are the fact that in C# we use the word const, C-O-N-S-T, which is a keyword, and in Java it's the word final. Other than that, they work very similarly to one another. So a variable in Java can be made into a constant by adding the final keyword before the data type. Alright, it means that once you assign it, it can't be reassigned. So we can have a local constant like you see there, final double pi equal 3.14. That means every time you use pi, it'll be replaced with 3.14. When you declare, which is this, and when you initialize, which is this, that's the only time that the variable can appear on the left-hand side of an equal sign. You can also take classes and instance variables and declare them as final. We talked about this a little bit earlier. If you declare a class or an instance variable as final, that means the class cannot be instantiated. The class cannot be extended. All right, and if it is a final method, it cannot be overridden. All right, there may be a very good reason for doing that. I was always taught that you should try not to do that. Another place it says there where the final modifier may be applied is to method parameters to make them unchangeable. Okay. All right, compile time and runtime constants. Says, as in most other languages, Java has both compile time and runtime constants. However, only class constants can be compile time in Java, and only if their value is known at the time of compilation. All other uses of final will create runtime constants. With compile time constants, the compiler will replace it. All right, so they're faster. Let's cut to the chase and say, what the heck does that even mean? If something is done at compile time, that means that when the program is compiled, the value has to be set. The value cannot be changed. The compiler needs to know exactly how much space to put aside to be able to do whatever operation it is it wants to do. On the other hand, if something is runtime, all right, and compile time is known as being early binded. With runtime, it's known as being late binded. The compiler does not have to know the size of something, because you may ask a question when you're running the program, or based on the value of a variable or whatever, based on what's happened before in the program, you can set it as it says at runtime. So look at this. E is always 2.72. But here, when we use this, it's going to figure out a random number, but at runtime. So the author says, in general, it's a good idea to always declare variables as final if they don't need to be changed. That prevents bugs that can happen. All right. Now, when you work in other languages, and you're going to see some of this when we talk about Android, but I'd say even more so in the iOS world, they basically recommend that when possible, you take every variable you have and you make it the equivalent of a final. And you do that because it's the old methodology of set it and forget it. All right. Again, many of these chapters are short, so I'm to the end of chapter 16. Before I start on 17, which is on interfaces, I'll take a quick break here.